Hey guys, we're going to continue working on these conceptual problems that you can find on the ACT math exam. These problems are usually found between number 30 to number 60 on the exam. I've selected these particular problems because the students that I've personally trained, they seem to struggle with these the most as a whole ever since this exam's been published. So with that in mind, I've selected a few that I want to go over with you guys, and hopefully they will help you. All right, let's move on to the first one. All right, so this one asks, the angle is between 90 and 180 degrees, and they tell us the sine is equal to 20 over 29, but they say, well, what is the cosine? Okay, so there's a couple of things going on here first. We're going to have to look at this from the perspective of the triangle and from their parent waveforms. So the first thing we'll do is we'll look at it from the perspective of the triangle so we can calculate the cosine. So here's our triangle. Here's our right angle. I'm going to look at the triangle from this angle over here. Let's call it A. Let's call this B. Let's call this C. Now that makes this side the opposite. That makes this side the adjacent. And then the side across from the 90-degree angle is the hypotenuse. Okay. Now, you know the sine equation is the opposite over the hypotenuse, and you know the cosine is the adjacent over the hypotenuse. So I'm betting that everybody knows these two formulas. They're going to be important. So therefore, since the sine is the opposite over the hypotenuse, the opposite side is 20. The hypotenuse side is 29. Now we can use Pythagorean's theorem to calculate the adjacent side, and we need to. With that being said, we would say 20 squared. I'm going to call the adjacent side B, and the hypotenuse is always C. So 20 squared is 400. 29 squared is 841. Now we're going to subtract the 400. So we're going to have B squared is equal to 841 minus 400. And that's going to be 441. That's B squared. So we're going to take the square root of that. And we're going to find out that the adjacent side, or B, is equal to 21. So now we know the adjacent side is 21. Now we need to think about the sine and the cosine waveforms relationship, because they're telling us the rule. The angle is between 90 degrees and 180 degrees in the problem. So the parent function for the sine wave starts at the origin and goes up, comes back down, 360 degrees later, ends back at the x-axis. The parent function's +1 and the -1 for the amplitudes. That's the sine. Now the cosine is just the sine wave shifted to the left by 90 degrees. So it's going to, instead of starting at the origin, it's going to start on the y-axis at +1. And it's going to come down all the way to -1 and then come back up until it makes one 360-degree rotation. All right. Now remember, we're interested in the area of the graph of 90 degrees to 180 degrees. So we need to put on here where 90 and 180 degrees is. So I'm going to show you on both where they're at. So 90 degrees on the sine is here. I'll write up here sine, and I'll write down here cosine. All right, so another 90 degrees would be 180. Another 90 is 270. And then another 90 is a 360. All right. That's our sine wave. For our cosine wave, we start here, and that's going to be our 0. And then we go 90 degrees to right here. There's 90. Then another 90. There's 180. Another 90 is 270. And then coming all the way back to the beginning, or one full rotation, is 360 degrees. Now remember, we're being told that the portion of the cosine that we're interested in is between 90 and 180 degrees. So look at your cosine graph. The portion between 90 and 180 degrees is right here that I'm coloring over. And notice that's negative because it's in the negative quadrant. So therefore, our answer is going to be 21 over 29, and it has to have a negative sign with it. And that's answer choice H. Now, I know that's a lot. Some of you may know the sine waves and the cosine waves, waveforms. Others of you may not. It just depends on how your Algebra 2 course has been structured. And perhaps they hold these sine and cosine waves and tangent waveforms until pre-cal. I'm not sure how they do that with your particular school, but here's some background to really help you. Let's go to the next question. So the next question is just a function, and it says, what are the real values of t for which f of t is equal to t? Well, we know f of x is 2 divided by x plus 1. So let's just rewrite that with f of t. So f of t is going to be equal to 2 divided by t plus 1. Okay. Now, look at your answer choices. Let's start with 1. That's the easiest. Let's start with the number 1 and test it. So we can say f of 1 is equal to 2 divided by 1 plus 1. So that's 2 divided by 2, and that's equal to 1. Now notice, our result 1 is the same as t. So that works. So let's test another number. Let's test it over here on the left. Let's test, I don't know, let's test -2. So f of -2, that's going to be equal to 2 divided by -2 plus 1. Well, 2 divided by a -2 plus 1 is a -1. And that becomes a -2. Now notice, our result of -2 is the same thing as t. So therefore that works. So we know 1 and -2 work, so those are gone. Well, what about 2? F of 2, positive 2. 2 divided by 2 plus 1. That's 2/3. So 2/3 is not the same as t. So that doesn't work. Well, what about -1? Well, let's test -1 right here. F of -1 is going to be equal to 2 divided by -1 plus 1. That's going to give us a 0 in the denominator. That won't work because it's undefined. So we've tested 1, -1, 2, and -2. The only ones out of this that's going to work is 1 and -2. And that's answer choice C. All right. Let's move on to the next one. Oh, this is a neat one. A lot of people struggle with this just because of the mechanics of it. And sometimes, they see the negative exponents and they forget to move the exponents from the denominator to the numerator or vice versa. With that being said, let's go ahead and start working on it. So which of the following is equivalent to what we've been given? So we need to simplify this. What we have here is 2a raised to the -1, the square root of b, all of this raised to the 4th power, divided by ab to the -3rd power. Now remember, we got to move these exponents around. But before we do, we need to get rid of the parentheses. So 2 to the 4th power is 16. And a to the -1 raised to the 4th power is a to the -4. Now the square root of b raised to the 4th power. I'm going to write this over here below the image so we can talk about this. Because what it ends up being is it ends up being b squared. And let me show you mathematically why it's b squared. All right. So the square root of b raised to the 4th power. Now the square root of b there's like a 1 and then a 2 out here. We can rewrite that as an exponential where it's b to the 1/2 power. If we raise b to the 1/2 power to the 4th, then we can get b to the 4 halves. 4 halves is equal to b squared. That's why b to the square root of b raised to the 4th power is b squared. All right, so now we got that idea cleaned up. Let's go ahead and take care of our negative exponents. So I'm going to rewrite this and say, I'm going to move the b to the -3 to the top and leave b squared. And then I'm going to move a to the -4 to the bottom. All right, now they're all written with positive exponents. Let's simplify it further. B cubed times b squared is just b to the 5th. And then a times a to the 4th is just a to the 5th. Now, which one of these of our answer choices fits what we have? 16b to the 5th over a to the 5th. That should be answer choice C. I think the real problem people have is taking in dealing with the square root of b being raised to the 4th power. So that's our side note below the figure. Make sure you understand that. All right. So the next one we have an automobile license plate number is issued by a certain state. It has 6 character positions. All right, so we're going to have 6 character positions. There's 2, 3, 4, 5, 6. Each of the first 3 positions contains a single digit 0 to 9. So 0 to 9, 0 to 9, 0 to 9. So that's actually 10 numbers. And it says each of the last three positions contain one of 26 letters. So we can have a possible 26 letters in the last three positions. It says digits and letters of the alphabet can be repeated. So they can be repeated. How many different such license plate numbers can be made? All right, so this is a combination problem. So in a combination problem, we multiply everything together. So when we do that, 10 times 10 times 10 is going to give us 1,000. And then we're going to take 26, multiply it together, and that gives us a number of 17,576. All right, now let's finish our multiplication. So 1,000 times 17,576 gives us 17,576,000, or answer choice K. It's a combination problem. And when you have a combination problem, you simply multiply your combinations together. All right, a couple more, and we'll be done. So this one says the function y is equal to f of x is graphed in the standard coordinate plane below. So it looks like a sine wave because it starts at the origin. All right. But they're calling it y is equal to f of x. The points on the graph of the function y is equal to 3 plus f of x minus 1 can be attained from the points on y is equal to f of x by a shift of what? So they're asking you, if we look at this equation, y is equal to 3 plus f of x minus 1. And it says the points on the graph of y is equal to 3 plus f of x minus 1 can be attained from the points on y is equal to f of x by a shift of what? So how does y of f of x in this equation y is equal to 3 plus f of x minus 1 differ? Well, I'm going to rewrite this like this. F of x minus 1 plus 3. So we have the function f of x minus 1, and we're adding 3 to it, right? So that plus 3 is going to make the graph shift upward 3. Now, what does the x minus 1 do to our graph? Well, since that's a negative number, that means it's going to shift it to the right. So we're going to go 1 unit to the right and 3 units up, which is answer choice A. All right. So here comes our circle problem. And it says we have the equation x minus 7 squared plus y minus 8 squared is equal to 10. And they say that lies on a coordinate plane. One endpoint of the diameter of the circle has y coordinate of 11. What is the y coordinate of the other endpoint of that diameter? Okay, so with that being said, what we can do is I'm going to sketch a graph, and hopefully this will help. So let's see. We know from this equation x minus 7 squared plus y minus 8 squared is equal to 10. We know that the center of the circle, which is our h value and our k value, our h value is 7, our k value is 8. We know the center of the circle is at 7, 8. All right, so we need to get quite a few divisions up here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let me keep on going. 12, I'm going to say 13. So now that's 13. And our H value is 7. So that's got to be 1, 2, 3, 4, 5, 6, 7. So there's our 7, 8, 9, 10, 11, 12, 13. There's our 13. Okay. Now, 1, 2, 3, 4, 5, 6, 7. Here's 7, and we need to come up 8. 1, 2, 3, 4, 5, 6, 7, 8. Here's 8. So I'm going to coincide those together right about there. There's the center of our circle. So that's going to be our 7, 8. 7, 8. That's our point, center of the circle. Okay. It tells us that one endpoint of a diameter of the circle has a y-coordinate of 11. All right, so let's count from 8 all the way up to 11. 8, 9, 10, 11. We'll come over, and 11 is right about here in this point. So our circle has an endpoint right there at 11. And the question says, what is the y-coordinate of the other end point of the diameter? Well, all right, so from 0.78 to 11, that is our radius. So 8 to 11 is how many units? Well, our radius is going to be 3. So if we go down 3 more, we should end up here at 7, 5. So the other endpoint is going to have a y value that's going to be 5. Answer choice J. Because, let me just do the math for you. So 8 minus the radius of 3 is equal to 5. That lands us at this point, 7, 5. So answer choice J. All right, we got one. I think this is the last one. Now, with that being said, let's go on to this one. The plans for a diving pool call for a rectangular prism. So a rectangular prism, the idea of a rectangle comes into mind, that has a length of 30 meters, a width of 25 meters, and a depth of 5. Okay. So let's just, let's sketch this one. I'm going to draw it like this. We know it has a length of 30. We're going to call this side the length. We know it has a width of 25. We're going to call that 25. And we know it has a depth of 5. So there's 5. Now, it says if the plans are changed to increase both the length and the width of the pool by 10%, what will be the increase in the volume of the pool? Okay, so we're going to call this volume 1. And that's just going to be 25 times 30 times 5. And that's going to multiply to give you 3,750. Now, if we increase each side by 10%, the new values are going to be a little bit larger. So the 25 becomes 27.5. The width becomes 33. And this depth becomes 5. All right. Now, we're going to call this volume 2. 27.5 times 33 times 5. When you multiply all three of those together, we're going to get 4,537.5. Now, what is the percent increase? Let's put percent increase up here. Percent increase. So that's going to be equal to 4,537.5. You're going to subtract the 3,750, and you're going to divide it by what we started with, the 3,750. Now, when you do your mathematics, you come out with 21%, which is answer choice D, as in dog. Okay. With that being said, I don't want to carry this video out too long. And those are some of the questions that some of the students that I trained specifically struggle with the most. If you're using this December 2017 exam to study with, I hope that you've ran across this video and perhaps you have found a little help with perhaps one of these questions. Remember this, the last half of the ACT math exam is more conceptual, more logical than the first half. The first half is really about mechanics of mathematics. The last half of the ACT is more conceptual. So focus on the logic of how we solve the questions, and that will help you the most. With that in mind, I wish you all the best on your preparation for the ACT exam, whenever you may be taking it. And if you ever need any help, feel free to reach out to us. Our contact information is below. Okay, you guys have a great day.